So today we're going to talk about sensors. In order to talk about sensors, it's worth having a quick touch on inputs and outputs because it's a really important part. So inputs and outputs, you might have seen that already within some of your computing science curriculum. It might be words that you kind of know are part of computing, but you're not quite sure what they are. So here's a quick overview. So an input is a bit of data, something that happens that the computer receives, something that we put into the computer. Our microbit is our computer, so something that we put in. And then normally what happens, you see the diagram at the bottom is the usual typical diagram. After there's an input, there's a process. There's a bit of code that runs that says, if this input comes in, this is what I want you to do. And then the output is the thing that goes out. So if we think about it in terms of our microbit, oh, the camera's still on, our input might be a button. So on the front of our microbit, we have two buttons, button A and button B. So the input could be press button A. The process is when somebody presses button A, I want you to show the temperature on the LED display on the front, and the output would be the number appearing on that little LED display on the front. So sensors are all about inputs and outputs. So I am going to start with this very short video, which is available to use with your learners if you want to introduce the concept of inputs and outputs and the sensors that they might get to explore. So let's do.
An input device is any piece of hardware that allows us to send data to a computer. So if you type a message on a keyboard or touch a screen to make something happen, you are using an input device. An output device, on the other hand, is any piece of hardware that allows a computer to communicate information to us. For example, displaying a message on a screen, playing a sound via a speaker or headphones, or printing a document. So, if you want to play music on your phone and press play on the touch screen, you are using an input device to tell your phone to play the music. The phone will then play the music and the sound will come out through an output device, your headphones. The BBC Microbit has several built-in input and output devices. The input devices are the buttons and the sensors for light, temperature, acceleration, and magnetism. The main output device is the LED display. Your microbit can also send and receive information by radio, so it's both an input and an output device. You can also add input and output devices using the pins on the microbit. For example, you can attach headphones or a speaker as an output device. If you have the latest version of the microbit, there are two extra inputs, a microphone for sound sensing and a touch sensor on the gold microbit logo. So you can program your microbit to react when you touch it. There is also an extra output, a built-in speaker to let you play the sounds you create instantly. So you can interact and create even more with your microbit.
So that video is available if you want to share that or play that within your class with young learners, just to give them an idea and a bit of an understanding of some of that vocab in computing in terms of inputs and outputs and some of the sensors that they might learn to use as they are using the microbit. The other thing, so we touched on this yesterday, so apologies for any repetition, but just in case, when you got your donation, you probably got a poster in with your donation. Lots of people have missed that on the back of the poster there's also this is a double-sided poster, but normally on the folded side this is half of the image on the screen at the moment, but it's a great poster that shows you, it labels up what the different inputs and outputs are and the different sensors and stuff like that. So that's a great one if you haven't spotted that and you're not using it to put on your walls. A quick shout out for the fact that if you want more of those posters, perhaps you want to have them in multiple classrooms. If you jump into the Microbit website, into the teach section, there is where the posters are available to download, but there is a small line underneath. If you're part of the UK, you can request additional copies of them to be sent out in the post. So perhaps you might want, I think there'll just be one in the donation box, but you may want more at other places in the school or in your class. So you're very welcome to order some more from there. So as I said, some of the inputs and outputs there. Today, we are going to look at using temperature, which is on the back. We're going to use the microphone later on as well. And we're going to use the temperature sensor. We're going to do the light sensor and use the microphone for sound. So I think lots of people have joined us and are settled in. So this is where we're going to get coding. If you want to code along, you are welcome to jump over and go into the Make Code site. So I'm going to move this round just now. And so it's makecode.microbit.org. And when you go there, let me just, in case you haven't been there before, you will arrive at a page that looks like this. You don't have to log in, you don't have to do anything, you can just press new project, give it a name. So we're going to measure some temperature as our first project. So I'm going to call it measure temperature so I can find it again. And this should be what you see when you arrive. So you don't have to code along with us. That's absolutely fine. You can watch and have a go. But if you do want to code along, then we're jumping over to Make Code. For anybody who didn't join us yesterday, our Make Code is completely new, very much like Scratch. So it's got a selection of blocks that you can drag and drop in. So on the left-hand side is our simulator. So anything that we do in terms of our code, hopefully will show up in there. Otherwise, we need to do a little bit of debugging. In the middle section, we've got our pick and mix selection of code that we may want to drag over and click in there, and then we just build up. So if I was to do, I don't know, some funny shape on the show LEDs, this would appear on my simulator. That's my bit of code. And if I decide I don't want any of that code, I can just click it, throw it back in the middle and tidy it up. So very much the similar feel to Scratch, just slightly inverse. So with just a couple of lines of code, we're going to use our first sensor. So one of the great sensors that the Microbit has is a temperature. So I am going to suggest that we're going to use the input of press button A. So we're going to go to the input section, which is the pink section, second one in the list. And we're going to grab on button A pressed. So it does what it says in the tin. If we press button A, this is what I want you to do. And I'm just going to ask it to show the temperature. So temperature is going to be in a number. So I'm going to go to the basic section and grab show number. At the moment, it's going to show 0. That's not helpful. But I know because the Microbit has an inbuilt temperature, those measurements are already there. So I'm going to go to input. I'm going to scroll down, and I can see some of the things are already there, contained within their own variables. And the one that I want is temperature. So I'm going to pop that in there. Now what you're going to see is nothing actually happens on the simulator at the moment. And why is that? Well, that's because actually I'm waiting for a trigger. I'm waiting for this input. So the input I'm looking for is press button A. So if I press button A, it's now going to show a temperature. So it says 21. And what hopefully you saw was this little bar appears down the left-hand side. So that allows me, without having to download the code, I can experiment and go, is this really working? So I've changed the temperature. Now it says 35. Okay, still not convinced. I'm going to drop the temperature down to 7, and it shows 7. So with just 3 blocks of code, I could have turned my Microbit into something that's going to read the temperature, which obviously is quite exciting, given that we've had all sorts of heat waves. There's all sorts of interesting ways that we could have used that. And in fact, one of the projects that you might see on the project site, on the Microbit project, on the website, on the Microbit projects, there is some code for maximum and minimum. temperature. So it'll sit there all day and it will store the maximum and the minimum temperature, which is what we did during the heat wave with my children at different rooms. Unfortunately, they left one of them in the kind of glass room conservatory bit at the side of the house. So our maximum temperature one day was 50 degrees. And thankfully, the microbit was still working afterwards. So how did the temperature change? So there is this little slidey bar on the left-hand side. So when you, I wonder if we can make that a little bit bigger. So I can change that up to 40, press button A again, and it will read it as 42. Should put my glasses on, change it back down. So it gives me a chance to kind of play around, test that I'm happy with those features working before I download that code onto an actual microbit. So hopefully that helps. Yeah, perfect. Great, let me make that smaller. So there was a really super quick way of just using one of the sensors instantly, not too much code, but lots of potential to then take it out of the classroom, take the temperature in different areas within the school, inside, outside, near the radiator, farther away from the radiator, all sorts of bits and pieces. So as Brian says, that was us simulating that the temperature change, but what will happen if when you put that code on your actual device, it's reading the actual temperature. So you won't be able to control, you won't have a slider going up and down, it'll just tell you in the same way as another digital thermometer will tell you what the temperature is. Excellent. Okay, so doesn't look like there's any questions there. Oh, I hear somebody unmuted. No. I thought I heard a noise, maybe imagining it. So next thing I would like us to do, so I've talked you through that one, and what we looked at yesterday was there is also the way where you can not necessarily have to talk your learners through some code. You could just give them the building blocks that they need and they're going to build something. So I have got something and it's called, I want you to go to this page. So it should look like that. So we are going to the page mbit.io. Let me just pop that link in there. 23 degrees. Oh my goodness. I'm coming over to Mrs. Ferguson's house because definitely think it's colder over here. Right, I'm going to give you a link. So if you want to look along, there we go. Brian's already on it. Excellent. Thank you, Brian. Ably assisted. So you should go to a page. In fact, actually, when we first go to the page, it will look slightly different. So let me just type it in for a second. mbit.io/pd code clap. When you first go to a page, so this is a page, I've made this page and I've shared this link. And when you first come to it, it'll look like this. And you can press edit on the left-hand side. And it doesn't matter if there's one person pressing edit or 15, 25, 32, however many people are editing it, it just edits a copy that you can see. So it doesn't change the code for anybody else. However, what it does allow us to do is support some learners that need a little bit of supporting, where where you can give them some code and they can you can ask them to experiment and try and make something happen. So I'm just reading the question. We haven't actually copied. We were just looking at the coding there, Miss Warrender. You can download, and we covered downloading yesterday. We can look at downloading again later on. I'm just exploring some of the sensors right now, and then we can test some things out on some actual microbits in a wee bit. But yes, absolutely, you can download it to your microbit if you want to actually know the temperature. So right now, this is a clap counter. So these are all the blocks of code you need. So if you're coding along with us or you want to have a look, then this is what you're wanting to do. So have a look at those bits of code. Have a think. How would you put this together so that every time I clapped and made a loud sound, it increased the number that it counted. So it counted the claps and then showed us. So I'm going to give you a minute for anybody who's having a look at that. If anybody's had a look at it and wants to share a screenshot, that was quite difficult. Share a screenshot of what they have made, or if anybody wants to drive me, so they want to unmute and say, I think I know what I want to happen. I'm going to ask you to move the blocks around. Just going to give you a minute or so to have a wee look, and then we'll look at that together. So let me just, the chat disappeared for a second. Okay, chat is back. Perfect. So in this one, if there's people just joining, I have shared some starter code that has all the building blocks that you need to make a very successful clap counter. And I'm just asking you to have a think about how you might make that clap counter. And we'll have a look together. So the first thing with the clap counter, because it's a counter, it's going to be counting something, so it's going to need a variable. And our variable here, as we can see, is the word claps. Now, all good variables need to be initialized at the beginning. So if you think about, if you've played any computer games ever in your entire life, what often happens is the score is set to 0 at the start. So on the start here, we're going to grab the claps and set it to 0. Sometimes it might be a timer that's reset in a game, or the number of lives you have. But in this instance, we're going to set the claps to 0 because we want to know how many claps it spots. And because of the microphone on the start, on the front of the microbit, it has a bit of code that it says, if I hear a loud sound, I'm going to do something. So we can see the 3 bits of code we have left. So it would make sense if we said, if I hear a loud sound, I want to increase the number of claps, so change claps by 1. So I'm adding 1 into the variable. Whenever I try to move the claps instruction, the whole screen moves. I can't move just claps. Oh, not sure about that. Let's have a look. Let's keep going here and I'll see if I can figure that out. Oh, yes, you do need to be in edit. So Mr. Armstrong, if you haven't, if you're just coding along and you haven't gone to that link that was shared specifically, then you can make the claps code by going to variable and making a variable and calling it claps, and that'll be how it appears. Otherwise, if you're using the link with the scaffolded code, then claps should already be there. So for a quick recap, at the start, we're setting the claps to 0 because we want to start afresh. We're going to say, when I hear a loud sound, I'm going to change that variable called claps by 1. So I'm going to add onto it, add my tally chart. But I don't actually know that that really happens. So I want to show the answer so I know and I can believe that happens. So I'm going to show number, and I'm just going to drag the variable in there. And again, when we're looking at the simulator, it gives us a bar on this side now. And it's got a little microphone above it. So it shows what the volume is. It's registered 128. So if I make that go high and then low again, and then make it go, high again, you can see how I'm increasing the number. So let's have a look. So I've managed to change that. Now, if I was to download that onto my microbit and do some clapping, I would be able to measure the number of claps that I gave. So perhaps it's the number of loud noises. So I know of a teacher who was using that to measure the number of door slams from a rather loud door in the classroom. So they were trying to encourage the young learners to not just let the door bang shut, but to close it nicely. And so they were measuring each day to see how many times the door was left to bang. So yes, we are going to, at the end of this session, later on this evening, I will also be sharing the presentation. So you will be able to get all the links to the different versions of the code and everything that we've covered in the presentation alongside the video. So we have used temperature. We did that quick one where we measured the temperature. This one had a few more lines of code, not too many, and we were able to measure claps. There is another nice bit of code. So that's the finished claps there. So you can see that's in the presentation for you to look at. The next one is this this bit of code here, which is quite a lot of fun to play with. So I want to show you, but also this is a great one to demonstrate to you. I'll talk you through the transferring your code onto a microbit. There's a great video that I'll share also that talks you through, but just so we've put one on our microbit during today's session. So we're going to do that one. I need to go to where the code is. So there we go. So here is my code. So this one is basically going to, well, let's have a look and see if we can figure it out. So we've got a bit of code. We've got the sound thing here, and you can see as the sound gets closer and closer to full 200, so everything's registered between 0 and 255. So as we get near the top, we fill in more of our LED things, and as we get nearer to the bottom end, so very quiet. So it kind of works kind of like those old amplifier stereos where it would, as you played music, the thing would go up and down. The last code worked on the microbit. This one doesn't seem to be. The sound one, Mrs. Marley, it needs to be a version 2 microbit. So it's one of the newer ones that came in the donation. So you can tell the difference between your version 1s and your version 2s. Version 1 has a flat edge at the bottom, so like a number 1, and a version 2 has a bumpy edge, a bumpy bottom. So that might be what it is. But also when you're using the microphone, depending on how much other noise you've got on, you might need to add an extra little bit of code to change the threshold that it's measuring, because we're all in different kinds of environments. Are there any reasons why the code wouldn't transfer from the laptop to the microbit? So you've got version 2, so it might be the threshold, Miss Marley. There is the code for the CLAPS project, I think, is online, so we can have a look at that. Don't know what the reasons are for the code not transferring from the laptop to the microbit, but let's just talk ourselves through it now, just in case that helps. So we've got our code, and we're just going to go down to the big blue. That's more purple. Big purple button at the bottom. And let me just clear off those ones. So I'm going to press download. As I said yesterday, I'm going to ignore the direct flashing. So you can set it up to directly flash, but I'm going to ignore that just so I can definitely see that I'm getting a file, and I'm taking that file and I'm putting it on my device. So it gives me the file in the bar at the bottom of your web browser. If you use that little up arrow and go to Show in Finder, it'll pop up. It'll always highlight the one that you've shown. So it's Sound Meter 2. I've obviously done a practice run earlier on, and I do need to, I haven't plugged in a microbit yet, so let me just get a data lead and disconnect this camera for a second. I'm going to plug in a microbit. So that should appear down the left-hand side here somewhere once it's found itself. There we go. So there's my microbit. And I'm just going to grab the file. I'm going to drop it on the microbit, and you will see that, oh, you won't see because it's put it on, I've got 2 screens. So you'll see it shows you that it's copying the message across. It takes a second. The other way you know it's copying the message across is if you flip your microbit over, there's an orange light next to where the power is plugged in, and that will flash when it's receiving some code, and then it will go to a full solid state color when it's not receiving code. So there we go. So I'm going to swap this over. So we've transferred that code. I am now going to switch cameras. Let's have a look if I manage to switch the camera there. No. I didn't
We're all waiting with bated breath, Lorna.
We are. I just unplugged the camera to put it on the Microbit because I just don't have enough USB ports in my life. And it's thinking about it. Oh, it's really thinking about it. Let me just try one more time. I will plug it back in. Little green light is flashing. Always wait for the lights to stop. And there we go. It didn't automatically switch over, but let me go to the camera here and work out if I can turn my camera on and off. Oh my goodness, I tested this a couple of times with Brian before you joined. I think it's just grumpy. Oh, was it working, wasn't it? Okay, I think it was just grumpy for a second because I unplugged it. There we go. So this
I think we're a bit behind you, Lorna. I was waiting for your little screen to catch up, I think.
Okay. Can you, oh, now I've got to find, so that's the wrong way round. We're going to turn it this way around. That makes more sense. So can we see my Microbit? I'm going to switch my light off so it's a bit more obvious. Can you see my Microbit? It should be responding a little bit to my voice.
I certainly can't see it in your little thing, in your little screen. I wonder if it's just frozen a little. You look as if you're frozen for me, but maybe that's just my end.
Oh, maybe. Let me just flick cameras again. So there's me, and then I'm going to flick the camera. Let's see if that is it working now? It shows me in the little window at the bottom. The camera is there. No.
No, not just now.
Sad times. Let me do one last switch off and on again. And switch that on. So
well, maybe what we can do is we can at the end just take a couple of like pictures with our phone or whatnot to take a picture of those things, and then we'll just post it up so we can see what that's like.
Yes. So what's the fun thing that I would normally show you on that sound one, which is a lot of fun when it works, is that, let me just put that light back on so I can see. Where's the cable? Can't find it. Is that it shows the flashing lights as I respond to talking, but then if you grab a piece of music and place that, so get your phone and play it near it, I recommend Seven Nation Army, but you can't generally do that on a call without a license. But if you're just playing around in class and playing some music and watching the bars go up and down to the different beats is quite a lot of fun, and sad not to be able to share that. Okay, have an experiment with that. That's a lot of fun. And then we'll just look at one more, let's move that out of the way, one more bit of code before we move on to the Microbit classroom. So when you put a bit of code onto your Microbit, you can then unplug it from the computer, leave it for a while, plug it back in. That code stays on that Microbit, so you can unplug it and then plug it into a battery pack if you're taking it outside, or leave it over the whole of the summer holidays and that code stays there. But the next program that you write and you transfer, that overwrites what's there. So it's whatever's the last program that's put on there that's stored in the memory. So think about it as a memory stick, but it can only take one program at a time. There we go. So very last bit of code, just to explore yet another sensor, is there is a wonderful project called the Nightlight Project, and that's using the light level sensor. So if we have a look at the code here, we'll just have a look at it on the PowerPoint, but we'll just take a little scan through how it makes sense. So this time it's in a forever loop. So that's an infinite loop, so it's just going to do that, as it says, forever, always going to do that. And it's got an if statement this time. So it's going to say if the light level, now it uses the light level is a sensor on the front of the microbit. So if the light level is less than 100, then we're going to switch on all of the lights. Otherwise, we're just going to have nothing on the screen at all. So this one works like a nightlight. So if I, let me just go here. So if I was to test it out in the simulator, so if you, I go to edit, so I can play around in the simulator. So there's my code, exactly as I showed you before. The light level is now this funny little circle that it's put on the top. And we go, if the light level is really high, so it's a bright sunny day, then we're grand. It's, you know, we don't need the night light on. However, if we make it all the way down the bottom, then it puts on all of the lights. So it senses what the brightness is, does something. At this point, we just want to put on a night light, put on the lights as a night light. But we could do something else. You know, we could send a message and say good night. We could do whatever we wanted to, but we have the ability to measure the light levels. And again, that light level ranges between 0 and 255. So 255 being full, the brightest it can measure, and 0 being absolute darkness. So that's the light level. Now pay a little bit of attention to that. So just have a quick scan through, because when we move over to Microbit Classroom, there's going to be some code for you to play around in there that is similar to this code. Okay, so when you are ready, I am going to, in fact, I'm going to talk to you a little bit about Microbit Classroom first. So not that one. First, I'm going to go to the presentation slide. So Microbit Classroom is a tool that we have. It's a free tool that allows you to share coding in a classroom environment. And that could be in a physical classroom. It could be, you know, heaven forbid, we have to do some remote learning again. It happens over the internet, so in whatever guise that you might need. It is web-based. It's free. There's no software to install for it, so it completely runs over the web. The important thing here is there's no usernames, passwords, or logins to manage. So unlike having to reset passwords or remind people what logins are, this works in a completely different way, so that you don't have to do any of that admin and management. You have the ability to capture the whole class as projects. So you could download, you could get to the end of a class, download what's happened so you can use it for assessment purposes or to get an idea of what's going on, or to resume and carry on some work at a later date. And it's a really easy way, as I'm going to show you, to share some starter code. We shared some starter code in a different way earlier on, but this is another way you can share some starter code with students, but also have an idea of what they're doing and how they're getting on. So if I jump back here for a second and go to this one. So when you set, I can't show you setting up just yet because I've got rooms set up for us as we stand at the moment, but you basically type in a name for your classroom and whether it's going to use MakeCode or Python, and that's all you need to do to get started, and you're taken to a page that looks like this. And then what you're able to do is you are able to put in some starter code. So I've put in some starter code and I've pressed share with students. So everybody who joins my classroom, this is what they'll get to see at the moment. Halfway through my class, I could change up what I want to do and share out with the students. I can keep doing that on a live basis, absolutely. And then I can then just put up on my whiteboard or share over Glow, Teams, Microsoft Classroom, whatever you're using, I can share the joining instructions. So for this particular classroom, so this is classroom number 1. Now the caveat here is 30 people can fit in a classroom. So I've set up multiple classrooms, but if you're quick off the mark, then you can go to microbit.org/join. And when you go there, you're just selecting, in fact, let me go there now. So microbit.org/join. And you come to this page. So this is how the students join. So they work out, you've told them the colour, the animal, the transport, the object, and they've given them a pin. So my colour is green for this room. It's a rabbit, it's a fire engine, there's a saxophone, and the number is 591285. So I can then, as a student, so I'm going to leave that there for a second. Where's the thing that shows me? There we go. So if I scroll down, I can leave that and I can see, oh, look, there's a couple of people already joined. So we've got Joe Thompson, we've got, oh, we're fast joining people. Now, once this room gets filled, I have 2 other rooms that I can share with you. But you can see who's joined in your class. So what I'm going to do while that's joining is there is, in case we get full, here's a couple of rooms. So let me see if I can make that slightly bigger and scroll. So if you can't fit into room 1, in fact, Brian's put them all in the channel, so that's great. So if you can't fit into room 1, then there's room 2, and then there's a spillover into room 3, and hopefully that's enough for everybody to get a chance to come in and see the student experience. So I've got people that have joined. Now, when you've joined, you can have a look at the code, see if you can move it around. This time we're making a sunlight sensor. So if you remember when we made a nightlight sensor, we said that when it got dark, we wanted to put all the lights on. So we want to pivot that, and we want to do, when it is really bright and sunny, we want to show an image of a sunshine on our screen to say, look, this is a really good sunny day. Have a look at doing that. What you'll see as a student does that is they can change around some code, and then they're able to, wonder if maybe I could join one at the same time. I will pick one to join. So let me just go to class 3 because there should be space. So let me quickly join so I can show you what it looks like for anybody who's not doing this live. Bass, saxophone. Let me quickly put the code in. So we've got 5.0.927. So what I see as a student when I come along here is I put in my name. So my name is Lorna. I've joined this room, and I'm able to move around some of my code. So I can have a look and say, well, I think that is it. And I can press the button, I'm finished. And I can say, I'm feeling really positive. I'm feeling really positive about that. I could sign out if I wanted to. I don't want to do that. I want to go back here and see if anybody has done any code. So there's, oh, I must have joined. Which one did I join? Anyway, so Lorna is happy and finished. So I could jump in and have a look and see what she's done. Oh, so that's a different Lorna. There's more Lornas in the world. Awesome. So I can see the code that they've done. I can have a look and go, okay. And I can even go back and say, where's that thing? There we go. I can say, actually, you're not finished. I want you to have a look at that. For in a classroom situation, I could have a conversation. It would come back and say, you're not quite finished. But I can see where people are. So I can see people are finished. I can see where they're happy. If anybody puts an unhappy face, I might want to dip in and go, you know, if Cheryl had put an unhappy face, I could have a look and go, Cheryl, don't need to worry. You know, you're doing brilliantly. And then I'm able to, at the very end, if I want to, I can download my whole class as a Word doc. So I can see where absolutely everybody is and how they got on. There's a bit of movement in the chat channel. So while people are still playing around here, and Cheryl, I hope you don't mind if I leave yours on the screen. I'm just going to have a look in the chat. So an account on the, so let's message there first. What does that say? Managing to send the code from my Microbit app to the iOrbit, but can I also send it to my iPad from the MakeCode site? If you create an account, you can access creations on any device. Okay, I think that's been answered. So you generally don't, there's generally not accounts on MakeCode. So the MakeCode site, you can just, go to MakeCode. We saw at the start before, if we go back to home, there's no account situation. You just make a project and they will stay. If this is a computer you use a lot, they will stay there. Otherwise, if you're a student and you're saving bits of work, you would get them from, you would download them, you would find them in the show them in Finder, find where the file is, and then you would put it wherever you normally store any creations that you make on a computer. So it might be, you might have a class drive, you might store things on OneDrive, you might store things on a memory stick. Lots of schools seem to do things in a slightly different way, but you'll have that file which you can find in Finder or Explorer, depending on what kind of device you're using, and then you can just drag it and store it in the same place there. So perfect. Okay, all good. So I think we are doing well. Any questions, feel free to pop them in the chat. Let's have a look back here. Oh, there's so many happy faces and finished people. So well done, everybody there. But hopefully that's given you a flavour both of what you see as a student, the student-facing side, but what you can do and what you can control, and how you can have a kind of dip in and out and see how people are getting on with various coding challenges. Now, they could all be doing the same thing. They could be doing different things. I could suddenly go, okay, everybody's flown through that. I'm going to go back to the editor and I'm going to export out to them a whole load of other bits of code. So there's a huge potential there. So I hope that makes sense. And any questions, save them up to the end, pop them in the chat now, whatever suits you best. But I'm going to start wrapping up now in terms of just a quick summary of bits and pieces. I zoomed in before for the stuff, so let's zoom back out. Just a quick summary of the different places and bits of information you have. So I mentioned this one before, so microbit.org/teach. There are all sorts of teaching resources in there, computing glossaries, lessons, all sorts of bits and pieces. Within the classroom resources section, that was when we were talking about the poster. If you want to order more posters, feel free. In there also are some lovely certificates if you want to celebrate achievements and coding with the microbit within your class, and there's some lessons stuff in there. We also have the projects part of the site. So Teach, when you go to the microbit site, there's the black bar at the top. So Teach was there, projects is next to it. So projects are a whole load of short projects. They're broken down in beginner, intermediate and advanced, code, Python, all sorts of content getting added there all the time. So have a look. Some of the projects we've done today are there. They've got some step-by-step videos. And then Do Your Bit is where projects are being organised in and around the UN Global Goals. So if you're looking at them at any point, there's some great resources in there that you can have a look at. We also have professional development. So on our website, microbit.thinkific.com. So if you have made a start in yesterday's session and today, but you would like to go on and do a little bit more professional development, maybe explore something a little bit more, then we have these self-directed courses. They're a mixture of topic introductions and some practical projects. And for each project, there's a teacher guide discussing ways that you can explore this and introduce this with your class. There's also, if you wish to use one, there's a student step-by-step coding video that you can play in class or share with people that are catching up, or if people are working at their own pace. And accompanying each of these courses, there's a workbook that kind of summarises, everything that's happened in the course and the suggestion. And there is also a certificate of completion for each course, should you need that for CPD credits or review or any of that kind of stuff. I can see a couple of questions. I'll jump to them in just a second. And then just a final shout out, there is lots and lots of information on support.microbit.org. So have a look at that if you have any questions. But, we are really open for you to get in touch. So, get in touch with help@microbit.org. Any questions, any support that you need, anything you're just wondering about, don't hesitate to get in touch. Having a quick look, is the presentation available? Yeah, I'm going to share this on the This Is Microbit group in Teams. So that will go live a little bit later. I was going to introduce Python to our P7s, but is this too advanced for them? No, so I've done Python with some P7s and some P6s before, not specifically on the Microbit, just general Python. There is a brand new Python editor which will be launched later on this month, that has been designed to help scaffold a little bit more coding with the Microbit and Python together. So you might want to watch for that. That's about to be launched. I think the biggest thing, there's a maturity element that the P7s quite like about Python. They're using something that exists in the real world and it feels a little bit more grown up sometimes. And they've done a lot of block-based coding. They like to, feel like they've made some progression in that sense. And it's just, it's not forgiving in the same way as block-based. So syntax is important, spacing is important, spelling mistakes, and they're all good life lessons. So, I've had lots of mileage working with P7's classes and doing that spot the difference. Here's the code on this person's computer that's working and your code is not working. So let's spot the difference and work out where the difference is. And it's, maybe, it's a spelling mistake, or, oh, I didn't, I've got more spaces in my code here than that person has, and exploring and learning in and around, why grammar is important in a very generic sense. So, yeah, absolutely. Any other questions at all? Otherwise, thank you so much for your time today. We've got one more session coming up in a couple of weeks, which we are going to explore some coding and some ideas in and around cross-curricular, so where you can do some computing science by stealth and fit it into other aspects of the curriculum.